Hi everyone, welcome back. Today we're going to look at something very special. It's a microcurrent probe. This is a microcurrent probe made by C Microtech. A microcurrent probe differs from a regular current probe in that it measures in milliamps and microamps instead of measuring in amps. Amps are good if you're measuring motors, lights, and stuff like that. Microamps and milliamps is what you need to do embedded controller for low power devices such as battery power Internet of Things devices. The UCP100 current probe operates by measuring the voltage drop across an internal resistor between the Vout and the Vin. There's a few Vin. You have the Vin wide and Vin precision, and then there's also Vin X. That's where you wire in your own precision resistors. So inside there's a precision resistor. Once it does that, it gets a voltage drop, then it multiplies it 1,000 or 1,000,000 times. What comes in the kit is you get this probe, you get a wire harness that handles all different modes, a 48 volt power supply, a BNC connector, and a bunch of little clips and wires that you can clip into. So today we're going to see how to use this thing on a Internet of Things device. So we're going to use my trusty old TI sensor tag. So this is the Simple Link sensor tag, the second one. Inside there's a CC2650 with the pile of sensors attached to it. The radio is built into the chip itself. So what I'm gonna do is I'm gonna intercept the power, and then I'm gonna attach something to the I2C line so we can monitor the amount of current draw as each sensor gets used. So how do I monitor the voltage, right? So what I did was I made this little thing. It's a little piece of paper, posted with some copper foil and 2 pins. So you take this, you put it on top of your battery, and you insert into the connector, like so. And then you wire a bunch of wires and stuff like that. But since the sensor tag is running these really small resistors, they're 0201s. So just like any old good cooking show, I have one already wired up for you guys to see. So I have the V out, V in through the piece of paper, the 2I2C, the ground connection, and this is VBAT. So I have an idea how much current I'm drawing. And I'm using the MSO-9212 today instead of the MSO-19 because I needed extra gain range. I also need the extra buffer to be able to see the data, see what's going on. So let's take a look at the data on the scope itself. Let's run the scope. Right now, this thing's been on for a while. So what it's doing is it's listening. It's broadcasting and listening. You see, because the other stuff is going on right now. Hold on, let me restart it. Alright. So it's going through the housekeeping, it's broadcasting, it's listening. You see different size and the duration that it's drawing. But one thing we don't see is we don't see any sensor activity because it's not longer linked up to the phone app, the Android phone app itself. So what we'll do now is we'll activate the phone app. Notice there's no I2C, so we'll connect the phone app itself. Once it starts connecting, it's going to start interrogating and ask for different activities available. And we're going to get the ambient, let's see if we can get the ambient light, lux meter. So it starts drawing the data. And on this side of the scope, you start seeing activity going on the I2C. So let's trigger on the I2C, trigger on the logic line. So you see the triggering is stopped right here. The different size packet looks like it's for different sensors. And by looking at that and looking at the source code itself, you should be able to tell what each sensor is drawing. So let's turn on one more trace. I'm going to turn on the function 1. Function 1 I had to set up for as um, A2 times A1. So basically it's going to give me the power. So boom, now I have the power. I can see how much power it's drawing. These little ticks in between looks like they're just they're time ticks. So I get some kind of housekeeping stuff that's looping within the CC2650 code, which we trigger on this packet. Notice the difference in the I2C packet, and then the waveform it's different. The current consumption waveform is different. This one has none. It looks like it's not reading anything. It should be a transmission. So let's zoom in a bit and see the I2C waveform. You see the let's see, zoom in a little bit more. So now you see the SEL, the SDA. So as each packet gets read, notice the power is moving out. It's the current, and then hence the power. And this beginning of the packet, the end of the packet, there's two different. The consumption rate is different. And let's look at the other sensor here. Okay, let's look at the other sensor. I think there's another one further down, right here. This one. So I'm gonna zoom in on the center of the screen. So assume this is center. Let's zoom in a bit. This sensor is a little different than the other one, which is a single byte read, or the current waveform looks very different than the one in the beginning. So, so the important thing to do on these power analysis is to make sure you have enough control on your firmware development, and you can watch as I move the lux meter. See the lux meter? I'm gonna block my finger over here. See how it drops? And on the scope side, we'll see a different activity going on. So there you go. This is the microcurrent probe. We're monitoring it using the MSO-9212, and this is how to do current consumption measurement for an IoT device. Thank you for watching.